Okay, so for this lesson, what we're going to do is we're going to solve equations by factoring. So the factoring part you know already, we're just going to extend it a little bit, and I think you're going to be fine. We're going to be actually dealing with something called the zero product property, and that just means that for any numbers a and b, if you multiply two numbers together and the answer is 0, then one of those two numbers had to be a 0, or possibly both. Okay, so again, this definition, don't let it bother you, but it basically is just saying for all numbers a and b, if a times b equals 0, then either a is 0 or b is 0, or both a and b are 0. Okay, so we're going to solve quadratic equations by factoring, which means we're going to solve for the variable. If necessary, and this is really important, if necessary, you need to set the equation equal to 0. And the equation has to be written in the standard form, which is this: x squareds plus bx's plus c equal to 0. You have to be able to factor it. So if you don't have the highest exponent written first, then it's not going to work. Once you are in factored form, figure out how to factor. Now, for us, the factor, we've only actually done 4 of these, or really 5. Factor by GCF, by dots, by IAM, or factor completely. We did not do the guess and test. We'll probably do that later. Once you are factored, you have to set each factor equal to 0. This is how we're using the zero product property. So each factor could be either a GCF or it could be a parenthesis. It doesn't, we don't know until we actually factor it. But you set every factor equal to 0. Once you do that, all that's left to do is solve for the variables. Okay? So let's see how this is going to work. This first one, solve the equation. Not only are you set equal to 0, but you're also already in factored form. So the fact that you're already in factored form, all you have to do then is draw a wall in between your factors. You're going to take what's in each parenthesis out and set it equal to 0. So x minus 8 comes out of the parenthesis, set it equal to 0. X plus 7 comes out of the parenthesis, set it equal to 0. And then you solve each basic equation. I would add 8 to both sides here and come out with the answer of x equals 8. I would subtract 7 from both sides here and come out to x equals negative 7. These are your two solutions. The reason why you know this, you don't have to do the checks for all of them, but the reason why you know this is if you checked with x being equal to 8, my first parenthesis would be 8 minus 8 times 8 plus 7. And then you get 0 times 15, and that in fact is 0. If you checked it with x being negative 7, then your work would look like negative 7 minus 8 in one parenthesis, negative 7 plus 7 in the other parenthesis, negative 15 times 0 equals 0, and it works. So all you're doing is figuring out what's going to make the equation equal to either 0, how it is, or whatever the problem, equal to 0. That's good. If you look at number 2, you are set equal to 0, so that's great, but you're not factored. So we've got to figure out how to factor this thing. We've taken this quiz already. There's two terms. There's a subtraction sign, and both of those terms are perfect squares. This happens to be a dots problem. So how do we factor this particular problem? And we would say it's y minus 8 and y plus 8 equal to 0. Now that you're in factored form, you drop your wall. You take what's in each parenthesis out. Y minus 8, set it equal to 0. Y plus 8, set it equal to 0. Solve each equation. So on this side, I would add 8 to both sides, and y is equal to 8. On this one, I would subtract 8 on both sides, and y is equal to negative 8. These are your two answers. And I know it's true because if I wanted to do my check and I stuck 8 in for y, well, 8 squared is 64, and 64 minus 64 is 0. If I plugged in negative 8 and I squared that, I'd still get 64. And 64 minus 64 is 0. So we're looking for two answers that when plugged into the original does what it's supposed to do, gives you a true statement. Let's take a look at number 3. In number 3, you're not set equal to 0. This is a problem. You're set equal to 15. So in order to set the equation equal to 0, how do you bring 15 from the right to the left? And the only way to do that is to subtract 15 from both sides, which means the right now turns into a 0, and the left, in the appropriate order to factor, looks like this: x squared plus 2x minus 15. Well, how are you going to factor that? It's got 3 terms. There is no GCF, so it must be IM. So if I think of 2 numbers that add to 2 and multiply to negative 15, I know my signs have to be different. 5 and 3 are the numbers that I want, but the way that I add to a positive 2, you want x plus 5, x minus 3 equal to 0. Those are your 2 factors. Drop your wall. Take each thing that's in the parenthesis out. So take each factor, set it equal to 0, and then solve each equation. When you subtract 5 from both sides, x is negative 5. When you add 3 to both sides, x equals 3. These are your 2 solutions. And it should make sense, because when you plug the stuff into the original, you're going to get 15. So here's how this works. Just going to kind of talk this through. If I were to square negative 5, I'm going to get 25. And then if I were now to multiply 2 times negative 5, I get negative 10. Well, 25 plus negative 10 is 15. That makes sense. It's supposed to. The other value should work too if you start plugging in the 3. Well, 3 squared is 9, 2 times 3 is 6, and 9 plus 6 is 15. So again, the idea is that whatever solutions you get when plugged in for x into the original equation have to give you a true statement when you're finished. Let's take a look at 4. Again, we're not set equal to 0. That's a problem. We're set equal to 10x. So what we need to do is be able to put this in factored form. We can only factor when x squared is positive. So what we need to do is subtract 10x on both sides. We don't have like terms. We just end up with x squared minus 10x equal to 0. We've got 2 terms and a subtraction sign, but we don't have perfect squares for both. So for that reason, this is going to have to be factored by GCF. GCF is an x. Opened up with a parenthesis, what's left over is x minus 10 equal to 0. We still have 2 factors. They're both not parentheses, only one's a parenthesis, but it's not a big deal. The factor on the left, the GCF, set it equal to 0, and you're solved. On the right, here's where you have to actually solve the equation, and x comes out to be 10. So your 2 solutions here are x to be 0 and x to be 10. And it should make, again, a lot of sense, because when 0 gets plugged in for x squared, 0 squared is 0. When that same 0 goes on the right, 10 times 0 is also going to be 0. So 0 equals 0. When 10 gets plugged in on both sides, 10 squared is 100, and 10 times 10 is also 100. So both those answers are correct. We are skipping number 5. We didn't do this type of factoring, so feel free to cross it out. Number 6 you need to do. This equation is not set equal to 0. So what that means is you've got to bring in what's on the right over to the left. The only way to bring it to the left is by subtracting it. And then you have to set up your problem so it's in the order that's factorable, which means the x squareds come first, followed by the x's, followed by the constant equal to 0. Well, this has 3 terms. I can't IM it, but there is a GCF I can take out. So this is going to be a factor completely. GCF is a 2. What's left over is x squared minus 3x plus 2 equal to 0. the polynomial that's left in the parentheses is a 1x squared, is an IM. So in the final answer, we've got to bring down the GCF, open up two parentheses, what's going to add to negative 3 but multiply to a positive 2, and that's going to be a negative 2 and a negative 1. And now when you drop your walls, you do have 3 factors, but the GCF doesn't even have a variable attached to it. So if we were to set 2 equal to 0, the GCF equal to 0, it doesn't even make sense. So this has no part in our problem solving or the solving for the variable. So the GCF does get thrown out for solving. But in here, take what's in the parentheses out, set it equal to 0, solve it, x is equal to 2. You added 2 to both sides. Take this thing out of the parentheses, solve for x, and x is equal to 1. Again, we're only looking for 2 answers. The GCF, because there was no variable attached to it, we didn't have to worry about solving for anything. This one with the GCF, number 6, and the one with the GCF that we just did on number 4, the GCF was a variable. That's why we had to solve for it. We didn't throw it away. On number 6, the GCF wasn't. That's irrelevant to us. Just go with the ones that have variables. That should be then enough to get done with the homework. Let me tell you that on the homework, problems that you can cross out. So number 6, cross it out. You don't need to do it. Let me see if there's anything else on here that you don't need to do. That's it. So just get rid of number 6 on your homework, okay? And good luck.